Hey YouTube, this is the Modern Einstein. This is the Science Talk segment. We're going to be talking about physics, and specifically in physics we're going to be talking about the very basics where physics start usually, and this is with the rule of significant digits. Some other names for that are significant figures and also abbreviated sig figs, I've heard them called. So a significant digit reflects the precision of a measurement. And before we get too much farther, I kind of want to give you the definition and the differences between accuracy and precision. These are two common terms that are used interchangeably when they shouldn't be. First of all, accuracy is how close to the measurement the actual value is. Okay? And as opposed to precision is how exact the measuring device is. So here with precision is actually how precise our measuring device is. And when sig figs come into play, it helps a lot because say we have two measurements, and one measurement's really precise and it's 2.01235 and it has a whole bunch of decimals. Well, we're going to add it with this other measurement and it's not too precise, it only has one decimal place. You can't mix those because it wouldn't be accurate, because we have a measurement with all this preciseness and all these decimals, and we're wanting to add it to one that's not very precise at all. So we use these rules to kind of fix that problem. So now that we can get started now. A significant digit. Okay, here's the rules. Any number between 1 and 9 is significant. You can see the number 528 here. All those numbers are between 1 through 9, so there are 3 sig figs, also meaning significant figures, significant digits, same thing. Okay, the next rule is any zero between 2 sig figs is significant. So here we have 909. Those two 9s are significant, and there's a 0 in between it, so that means the 0 is significant. Therefore, we have 3 sig figs. Okay, that's 2 of the 3 rules. We'll go down here to the third rule. Okay, any 0 after a decimal place, after a decimal or significant figure, is significant. So here we have 13.49. That 4 and 9 is after the decimal, and it's also after 13, which has 2 significant digits. So that 49 part is after a decimal and after significant figures. So therefore there's 4 sig figs there. So here, this up here is the basic rules we follow with sig figs. If you're taking notes on this, I'd definitely write that down. Okay, now when we actually do operations with sig figs, this is what we do. We look at the number with the least amount of significant digits. So first operations we'll cover will be multiplication and division. When we do multiplication and division, in this case we have 12.1 times 20.0. When we do, this is a key part here, when we do multiplication, we look at the total number of significant digits in each value that we're multiplying. In this case, there are 3 significant digits in both 12.1 and 20.0. So therefore our end result will have 3 significant digits as well. Say we had only 2 significant digits multiplied by 3 significant digits. You look at the total number of significant digits and you take the least amount. So your final answer would have 2. The rules change just a little bit when we do addition and subtraction. Here we have 12.7 times 11.35. In this case, we only look at the amount of significant digits after the decimal place. So we'd look at the 7, we'd look at the 535. and we'd look to see which value has the least amount of significant digits. In this case, the least amount of significant digits after the decimal place would be the 10.7. It only has one significant digit. So we know our end result could only have one significant digit after the decimal place. Okay, here it is, 10.7 plus 11.35. This is what it would be in a calculator. Okay, but that measurement is not accurate in physics, so we look at that too, and we round, and so it stays the same, because we can only have one digit after the decimal place. So the end result would be 22.2. These are your rules for significant digits. If you didn't quite follow, you can leave a comment or email us, and I will be glad to help you out and try to explain it a little bit better. But here's how they work, and they do make quite a difference in physics, because physics needs to be precise, and as opposed to the just mathematics, you don't have to worry about this too much. But in the world of physics, this is a key component. This is where physics start, and you build on top of that. So thanks for watching, guys. Subscribe, leave a comment, ask questions if you need them. Thanks.